Welcome to ClickMyProject.com. Now we are going to discuss about the project Scene Specific Dark Channel Prior for Single Image Fog Removal. Now we are going to discuss about the abstract of the process. One of the most interesting problem in recent times in image processing and computer vision is fog, haze and rain removal from the images. In this paper we shall consider the problem of haze removal. Here the latest haze removal algorithm proposed based on the dark channel prior approach for haze removal. We propose a process which is called the De-haze-Net for medium transmission estimation with DCP, that is the dark channel prior. De-haze-Net take a haze image as an input and then the output is medium transmission map, that is the subsequently used to recover a haze-free image via atmospheric scattering model. De-haze-Net based deep architecture layers are sequentially designed to extract the features from the hazy pixels, which can generate the almost all haze relevant features. We also proposed a nonlinear activation functions in De-haze-Net called bilateral rectified linear unit, which is able to improve the quality of the recovered haze-free image. Hence, majorly we have considered the DCP and transmission map to remove the hazy pixels in the image. Hence, the output of this process will be the haze-free image. Then the quality of the image should be the increase. Finally, the performance, using that performance we can justify our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. At first, the modules of this flow is input image, pre-processing, haze detection, haze removal, dehazing the image, finally the performance estimation. At first, the input image is taken from the dataset. The dataset consists of the images having the hazy pixels. After getting the image from the dataset, we just move to the next step of the process, that is the pre-processing. In this pre-processing, we have two kinds of pre-processors is there. One is the image resize, then the another one is the data type conversion. So in this image resize, the image size of the image will be resized into an 256 cross 256. Whatever the input size, it will construct the image into a size of 256 cross 256, which means the number of row and column will be the 256. Then the data type conversion, in this the unsigned integer 8 into 1 converted into one double format. After the pre-processing, haze detection and haze removal will be carried out. These two steps will be the interlinked steps, hence the haze detection and removal are done parallelly by using these three steps, that is the dark channel prior, transmission map and contrast enhancement. Using these steps we can enhance the quality of the image. If the haze pixel is present in the image, means it will be detected in the haze detection step. Then the removal step is done by using the transmission and contrast enhancement method. After that, the output of this process will be the haze free image, that is the de-hazed image. The de-hazed image consists of without having any hazy pixels, and then the quality of the image will be retains the good. After the haze removal, the performance estimation is done by using the PSNR and MSE. PSNR is abbreviated as peak signal to noise ratio and MSE is abbreviated as mean square error. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the main file 1.m and select the option run. Now the main file 1 will be executed automatically. After that execution, the dataset folder will be open. In that dataset folder, you have to select any one image from the dataset. After the selection of the image from the dataset, the corresponding image will be displayed one by one, and then the process will be proceed one by one. Now the overall execution was completed. Now I will explain the results one by one. Now this is the image which I have taken as an input from the dataset. After the selection of the image, now the corresponding image is shown in this figure with the title of input image. After the selection of the image, we just do the image resize. The image is resized into an aspect ratios because maybe the input image having the both the high resolution or else the low resolutions. To optimize the size of the image, we have to resize the image. After the image resize, we just applying the transmission map. Now you can see the two results, transmission and then the maximum transmission map. This is the kind of the interrelated results. In this one, the hazy pixels will be extracted. Maybe the pixels will be having the same intensities. Now the figure 5 shows the results of the input image, output image and then the finally fine-tuned image. Whether the output image having some noisy pixels, during the fine-tuning the image sharpening is applied to remove the noisy pixels as well as the improve the quality of the image. You can see the difference between the input image and then the final sharpened image. Now finally the classification result shows this is an high quality image. Now the PSNR is around 100%. Now the MSE values is like this. Finally the entropy of the input, output and then the histograms will be shown like this. Finally the histogram of input, output and sharpened image will be shown in this histogram chart format. Thanks for watching this video.